I will present today a live demo that is a preview of OSM Release 4, so I hope you enjoy it. I'll have to be down there because of the length of the cable, but I'll be there. Can you hear me? Okay, perfect. Okay. So we'll be exploring briefly what changes we are adding to the OSM Release 4 architecture. You will see that there's a lot of good stuff going on. And then 3 quick demonstrations around the new northbound interface, a lightweight orchestrator, the UI that is a new alternative to the current UI, and then some other demonstrations around performance management and fault management. So to get started, just a recap of the release 3 architecture. So what we have now is, mainly these components. We have a UI integrated to a service orchestrator, and the service orchestrator controls the functions of BCA, which is the one in charge of configuring BNFs after instantiation. And then we have the resource orchestrator that is in charge of the life cycle of the Beam resources. So we have some opportunities for enhancement here. For example, there was not a unified northbound interface for interacting with all the components as of release 3. There is an API, but it's limited and only hitting the service orchestrator. So that's an issue we noticed. Another thing is that the service orchestrator and the UI today are tightly coupled, more than they should. And this has become complex to evolve and also to receive more contributions at that model. Also, there's no obvious place to integrate new functionality, like, for example, external models that other contributors would like to integrate. So the changes that we are adding to the release 4 are basically these ones. You also already saw a similar diagram earlier. Mainly, we are adding a unified message bus, which is implemented with Kafka for asynchronous communications. And this is a huge opportunity to introduce new models and plug them to the system very easily. For example, the monitoring module and the policy manager module are relatively new modules that come with release 4 and provide policy management, fault management, and performance management. For example, things like auto-scaling, like monitoring, metrics, everything related, we can do it with monitoring module and the policy manager. The other thing we're adding is a lighter version of the current orchestrator. We call it lifecycle management component or module. And this is an alternative to the current orchestrator, which is called SO. Then we have the unified northbound interface, which exposes functions of the whole system. So that's also a huge advantage, because the clients that talk to OSM since release 4 now have more control capabilities over the overall system. So for example, the OSM client, that it already existed, but now it has more functions. And we have the opportunity to introduce a new UI that is completely independent from the orchestration model. So it's a standalone model. And finally, we have some common services shared by the whole architecture for it to become, for the components to become more stateless and the architecture as a whole to become more resilient, right? So a common database, storage, authentication, and logging systems for the whole system. So there's a huge amount of things going on in favor of making this project a production-ready NFV monostack. So let's get started with the demonstration. Would be just 3 quick demos as a preview of what you will see in release 4. So first of all, in this first demo, we will show how the northbound API can be used to talk to the existing models and the new lifecycle management model of OSM. So we have 2 ways to communicate with OSM. The CLI, that it already existed, but as I said before, it has new functionality as now it's talking to a more rich set of APIs. And we have a new user interface, which is lighter and is maybe more agile than the previous one. So let's take a look. OK, this is the what we call the OSM lightweight user interface. So it handles projects, so it's multi-tenant. It supports multi-tenancy. And we can, for example, handle onboarding of packages, of network services and BNFs, and launch instances from here. Also, we manage the Beam accounts from here. So let's take a look at, for example, the catalog of network services. We have 2 existing network services, and adding a new one can be as simple as dragging and dropping a descriptor. For example, I have a pre-built descriptor here, and I just drag and drop it, and there it is. And also, we can launch a network service based on an existing descriptor from here. We can also edit the descriptors and see the descriptors in YAML or JSON formats, for example. And let's take a look on how easy it is to launch a network service from this interface. And for that, I will show the OpenStack environment that we are connected to. This is just a vanilla distribution of OpenStack from Whitestack. Let me show you the topology. OK, so we have the existing BNFs there, and we can launch a new one based on this descriptor, for example. I just will give it a name, BNF1, and the account I will use, a Beam account I will use. And this creates the new BNF, which should appear here soon in this network. There it is. And well, this is basically the user interface. We will keep adding more things. This is just the first version. And you can also take a look here at the OSM client. So the OSM client has functionality like, for example, listing network services, or BNFs, or beams, and show the details about them. I'm just going to delete, for example, the new BNF we just created. And it should disappear from the beam, of course. There it is going. And from the network services list. So that's just a brief example of the new ways to communicate with OSM. As you can see, this unified northbound interface can control any OSM component through the bus. And of course, users can add other ways of interacting with OSM through different UIs or systems using the API. The second demonstration has to do with metrics collection and visualization. So here, the featuring model is the monitoring model down there. It basically communicates with the different beams through plugins. So we are communicating today with OpenStack telemetry system, VMware virtualized operations, and Amazon CloudWatch. And it can gather metrics from those systems and put them in the Kafka bus. No? And we can be selective about that. I mean, we can pick which BNFs we want to monitor. And once the metrics are there in the bus, we can integrate any system of our preference to make those metrics persistent and visualize them in a friendly way. For example, we are starting to propose a set of tools based on Prometheus and Grafana, but those will remain for now optional for the community to pick if they want to use them, with, of course, following the documentation that we will make available, or if you want to just plug your own system. What we are focusing in is in making those metrics available for any system to integrate. So right now, they are available at that Kafka bus. And the way they were making them available is, for example, like this. Of course, that's not user-friendly. That's friendly for the bus. And that's information that is allowed into the bus. For example, resources IDs, the value of the matrix, and the name of the metric. But that's enough for any monitoring system to transform it into something like this. This is from Prometheus, for example, that can gather any metric that is made available at the Kafka bus. Here's the CPU and the memory. But we think that's still not that user-friendly. Sorry. So we added Grafana, which integrates seamlessly with Prometheus, and we can see things like this, right? And this is better. So let's see some action there. I will try to access a VNF. Here's the VNF I launched before that existed here, the 0.8. So I'm going to log in. And I have a couple of scripts there to send a CPU spike. So we will do that. And it will elevate the CPU. I will see what happens in a minute. Well, maybe more, because it takes some time, this lab, to gather statistics and make them available to OSM. OK, so the metrics are there. And the Grafana system will eventually show that CPU spike. But in the meantime, let's take a look at demo number 3, which has to do with fault management. So again, we have the Kafka bus as a way to connect things, to connect models between each other. In this case, we have a new model which is called the policy manager. And the policy manager cares about what to do when an event is generated by any network service. For example, a CPU threshold is crossed, or a memory threshold, or maybe something related to the VNF, a number of sessions. What to do if things go start behaving differently. So the policy manager is capable of creating alarms into the beams, and it does it through the MON model, because the MON model abstracts this communication from the rest of the system. And it, for example, can create today an alarm on any beam that will trigger a notification as soon as a threshold is crossed. So for example, if an alarm has to do with CPU, and that threshold is crossed, then that notification would go back to the system, and policy manager will read it from the bus. And then when the notification is there, when the alarm is triggered, then the policy manager will decide what to do. It can have some default actions, or we can configure those actions previously included in the descriptors of the VNF. And for example, in this demonstration, we are just generating a log whenever a CPU threshold is crossed, and it goes, for example, 50% or more. The mechanisms that we are making available for users of OSM are to integrate with these logs or these actions that Policy Manager generates through the Kafka bus or through TCP in the case of logs. For example, if Policy Manager generates a log, it can be sent to another system through TCP on any port, or it can just be put on the Kafka bus and in a certain topic that is configurable, and an external tool can grab the logs from there and do something about that. For example, related to the previous example, we are proposing a set of tools which are this well-known framework called Elastic, Logstash, and Kibana, the ELK stack, that consists in 3 components. That the first of the stack is Logstash. It collects the logs and transforms them into any format we want. Then Elasticsearch implements a search engine around that. And then we can visualize what we are gathering through Kibana, which is just a dashboard that we can customize. So imagine this kind of system integrated with the manual stack. We can have a powerful visibility into the events that are associated with our BNFs. And as the previous example, this is just a proposal that can be used by end users. You can use the ELK stack, or you can use whatever tool you are already using, as long as you support integrating to the mechanisms we are making available. If the community proposes that we should support more mechanisms, we can do it so. So for now, we can send logs through TCP, or we can, excuse me, I don't know what happened. Well, or we can grab information from the Kafka bus. Excuse me? It was me, I'm sorry. So, OK. I knew I should take some copy. OK. So now we are going to see this. So this is how Kibana looks like. It, for now, is showing the logs in raw format. But what we can do some interesting things about this. We can, for example, save searches related to certain logs. For example, I want to see all the scale in or the scale out logs, and I can configure a filter and save it with a name, and then I will see the logs that I care. And then I can build some visualizations related to those specific searches, and then after I have the visualizations, I can build a dashboard. So imagine we can have any collection of events or collection of logs, filter it in any way, and build a dashboard both for system monitoring or for operators. So let's see if the CPU was rated. OK, we are reaching 100% of CPU now. So that would have generated a log in the policy manager. So let's take a look. Discover, and I will add my search that is related to scaling out messages. And I just got one, seems 5 minutes ago. And it says scale out. And it's triggered by the policy manager. Policy model core agent. So then I, for example, can see the dashboard and see that there is the amount of times I have received a scale in or scale out alarms during the day, or this is filtered by the last 4 hours, but I can filter it by 15 minutes or whatever. Okay. So in summary, the new OSM Release 4 architecture is fully Dockerized. I didn't mention that. I can show it. You can see here Docker, service, PS, no, ls, sorry. And there is all the components I mentioned, the Kafka bus, the LCM, the Light UI, the monitoring model, a Mongo database, which is a common database, northbound interface, policy manager, resource orchestrator, its database, and zookeeper. Everything runs in a single Docker container. So this gives us a possibility of building a strong architecture that is very resilient and highly available. Today it's managed by Docker Swarm, but we are working also to integrate Kubernetes. So it's fully Dockerized, and it's even lighter than before if we use the LSM module and the light UI. And it allows for new integrations via the bus, as you saw, or the northbound interface. And of course, as a reminder, we are ready for production environments. Thank you. If you have any questions?
What part of this scenario would you be able to some sort of correlate your PMs and alarms and everything?
Let's.
Thank you. So in that platform that you put together, which part of it would you be able to correlate some of these PMs and alarms and then put some thresholds on the alarms that you're getting, and then from the Kafka and forward it to northbound?
Well, it's the mechanism for doing that is already there. We just need to build the use cases. So we have everything.
So it would already be built in?
Yeah, the policy manager is able to take whatever action you can configure based on the events that are flowing from the infrastructure or from the VNFs. So you can send notifications to upper levels, OSS, for example, okay, based on that. So we're looking for more use cases to have those mechanisms in place. So it's just a matter of modifying a configuration file and not having to deal with the code.
And this didn't exist in the previous release, exactly, right? Okay. Thank you. Mm-hmm.
Hi, I'm Joan from Docomo. One question. For the monitoring functionalities, I've seen that basically what you have done on the log functionality as well. Gather logs from events that happen, or things that happen within the OSM stack. Is it restricted only to gather those type of events, or also to gather events of the VNFs themselves and the infrastructure?
Okay. What we saw there were events that were being triggered by threshold crossed by the infrastructure, for example. But we can integrate any kind of event, actually not as part of the first release 4 version, but for a subsequent release, we will add interactions with VNFs. So the VNFs will send events, and we will gather metrics through the N2VC module that will flow back into the monitoring module, and the rest is the same thing. So we will be able to handle metrics and events from the infrastructure, from the VNFs, or from the system in this release.
Okay. Another question. Everything goes now into this Kafka bus. Is this just one instance of a bus and everything goes there? Because I see that the Kafka bus, you also expect to use it to gather logs, to gather events, to gather PM data. Mm-hmm. But you also use it for the actual communication in between the components and the modules within the OSM stack, right? Is it going to be like this, or is it possible to define different buses for different purposes?
Well, yes. Basically, the models have two ways to communicate between each other. They can communicate directly for synchronous communications, and this bus is dedicated to the synchronous type of messages. And it can be divided in topics, and it can scale with, it was built actually, Kafka, to scale out and to handle streaming and real-time analytics. So yes, we will keep that single mechanism for asynchronous communications, but we are sure it can scale further. In the demo, of course, we only have one instance, but it can scale to many instances.
Okay. Thank you.